So my name is Jace Cussins. I'm a second-year master's student at Western as well. And my research focuses on the impacts restoration has on soil moisture in wet meadow areas around the Gunnison Basin. Next. So as has been mentioned, the common theme, as global temperatures rise and continue to contribute to drought severity in the West, ecosystem resilience becomes more important. And typically these wet meadow areas are generally resilient. However, degradation has made them less resilient. But as has been the main focus of these talks, restoration can help rebuild that resiliency of these wet meadow areas. So wet meadows store water for longer periods of time throughout the summer, providing a longer growing season for plants. So to assess if restoration is impacting resiliency, I'm looking at soil moisture. Next. So these are my research questions to answer these overarching question of ecosystem resilience. So I'm looking at, do these restored wet meadows retain higher soil moisture content across seasons compared to non-restored wet meadows in adjacent sagebrush areas? I'm looking at, are there differences in soil moisture between the shallow and deep depths within these different treatment types? And then lastly, do restored wet meadows have less days below the permanent wilting point than the other treatment types? Next. So to investigate these questions, I have 3 sites that are within approximately 25 miles or less of Gunnison. So to the east, I have Cabin Creek and Monson Gulch, and then to the west is Sapnora Mesa. Next. At each of these sites, I have 3 restored transects, 3 non-restored transects, and 3 sagebrush transects. The restored transects are placed just downstream from restoration structures and are expected to see direct impacts from restoration. The non-restored transects are located either upstream of all restoration structures, or I do have a couple that are quite a bit greater distance downstream from restoration structures. So they're expected to not see as direct of impacts. And then the sagebrush transects are located adjacent to the wet meadow in the sagebrush vegetation. And those are supposed to represent a degraded system where sagebrush would continue to encroach on the wet meadow area as things continue to dry. Next. So this here's my my sensor transect or soil moisture transect that I've set up. So I paired all of my soil moisture transects with vegetation transects. Those vegetation transects range in length, but let's just say they're 25 meters long. I placed the data logger in the center of the transect, and then going both valley left and valley right, about 4.2 meters. I had 2 sensors going down, one at 15 centimeters to kind of capture the root zone or that top layer of the root zone. And then at 46 centimeters to kind of see how the water is moving down deeper into the soil. These data loggers recorded the volumetric water content every 10 minutes. Next. So this is some of the data collected at Monson Gulch, May 18th through October 2nd from 2021. In general, the sagebrush had the lowest volumetric water content across the season, while the restored had the highest, and the non-restored transects kind of had an intermediate values relative to those other treatment types. The differences between all these different treatments were significant when I ran a generalized additive mixed model, but there was no significant difference found between the 2 depths. And then something also worth noting is where that black line is, MEM student Max Sawyer designed and implemented more restoration structures being installed out at Monson Gulch in the restored areas. And then just kind of looking at that green line, which is restored, you can kind of see some immediate impacts from restoration as that volumetric water content continues to increase, while in the other transect types, it continues to decrease. Next. So at Sapnora Mesa, the sagebrush transects, again, generally had the lowest volumetric water content, but the restored and non-restored transects had very similar values. But both those, the restored and non-restored, were generally higher than the sagebrush. And then that restored and non-restored transects were significantly different from sagebrush transects, but were not significantly different from each other. And again, the depth had no significant difference. And then it is something kind of neat and worth noting is there was a large rain event. I think it was approximately 34 millimeters on July 25th and really had a impact in the sagebrush transects. Next. I also looked at the permanent wilting point, or the point at which plants begin to wilt and die due to a lack of water. So on this graph here is focusing on the average number of days below the permanent wilting point. And so generally the restored transects at both sites had the least number of days below the permanent wilting point, while the non-restored and sagebrush had more days below the permanent wilting point. But the only significance that I found was between the restored and sagebrush transects at Monson Gulch, and that was at both depths. Next. So to conclude, I'll just kind of come back to those questions. So looking at, do restored wet meadows retain higher soil moisture content compared to the other treatment types? Yes and no. It appears to be site specific. So where all the treatments were significantly different at Monson, but you look at Sapinero Mesa and the restored and non-restored were not different from each other. That second question, are there differences with the depths? And no, at least for what I found, I did not find any significant difference in volumetric water content between the two depths. And then lastly, do restored wet meadows have less days below the permanent wilting point? And again, this is a yes and no. So we're at Monson Gulch, there was that difference between restored and sagebrush transects, but I didn't see any significant difference between the rest. Next. So then going forward, there's a new graduate student that's coming on the project that'll continue to monitor soil moisture with these soil moisture transects that I established, and possibly put in more if we have the funding. But that new student is also looking at new ways to monitor soil moisture. And so she's going to be looking at using drone and satellite imagery to be able to look at that soil moisture at a larger scale, which this could end up opening up the potential to do more sites, larger areas, and minimize and make more efficient while minimizing the fieldwork labor and cost of on-the-ground sensors. And then with that, I think my last slide is just a thank you. So.
Hey, fantastic job, Jace. Thanks for joining us today. Say hi to Chelsea for us, and look forward to seeing some baby photos here soon, okay? All right. And then actually, I just wanted to mention that we do have one really nice paper out there by Nick Silverman. What Nick looked into was long-term grazing management, the use of these beaver dam analogs, and actually he used some of the data from our Z-dike rock structure work here in Gunnison. He looked at NDVI to look at the vegetation productivity response. So we did see some great response. Again, 20% increase with the BDAs, and then 24% increase on average with our Z-dike rock restoration work. So the take-home message there is that these results are visible from space using satellites. So pretty cool. And I don't think we have time for any questions, but thank you very much. I know everyone's going to hang out a bit longer, so please catch us later on if you have any questions. Thank you.